Simon Ćwieka, but don't worry about the last name. You can call me Simon, and it will be okay. Welcome to the SIEM not only for security presentation. And if you have any questions, please feel free to ask them on the Huva application, and I will try to answer them as quickly as I see them. To be fair with you, I will be showing a presentation with screenshots of the system, of the SIEM. Those screens will be from CyberX system, which is ready for the POC, proof of concepts. So if you like it, then please contact us regarding that topic. And I think without further ado, we can start the presentation. So the first question is, what is the SIEM, and what is the purpose of the SIEM? So the purpose is to monitor architecture for security issues by analyzing data sent to that system. Meaning that if you have, for example, some firewall or application, you are sending data from that software to SIEM, and then the SIEM is analyzing that data, looking for issues. But there are few problems with that. The first one is that the data can be sent the data sent to the system are only from selected sources. So the manufacturer of the SIEM is creating a list of sources that are supported for that SIEM solution. And if you are, you basically cannot send anything that is outside of that list, because the system will just not understand the data you are sending, and it will be pointless. The second thing is that mainly only the security related events are sent to the can be sent to the system. Sorry, that is a little too loud. And mainly only security related events can be sent to the SIEM. So if you have any other system that is not supported and not related to security, like for example custom application, or maybe some business intelligence, or maybe just simple networking, then it is a good chance that you will be not able to send those data to most of the SIEM solutions. Thank you, Mr. Zidane, for warm welcoming. Nice to see you too. There is back to the topic, there is another point, that is the data retention. The data retention sent to the system is relatively short, meaning that the data you are sending even for analyzing, will be removed from the system shortly, because they are designed in different approach. They are designed to analyze the data, search for issues and point them, and those most of those systems are not designed to store the data itself. Then there is SQL databases. A lot of the SIEM solutions use SQL based databases, which we believe that it's not the best solution for that use cases, because SQL databases are not really the fastest one for this kind of software. So this kind of software like SIEM has to have large quantities of data, have to be able to calculate and aggregate that large amount of data really fast and then return the resources to the user, and SQL databases are not suited for such uses. Of course, you can use SQL databases, as some software use that, but it's a matter of just basically the speed of usage, the CM solution. And at the end, there is that the data sent to the system are often covered with metadata. What does it mean? Basically, it means that when you are sending the data from some software, the CM solution is looking and analyzing that data, and then it is adding some additional fields, some categories, like for example antivirus, malware, or I don't know, basically enhancing the data, grouping those events and so on. And don't get me wrong, this is good. CM solutions should be enhancing the data, so this is good that they are doing it, but we think that there is a missing point here, that while they are enhancing those data, they are also removing the raw data that has been sent to the system. So you can't see the original data sent to the CM solution. You can see only the fields, the metadata, and the summary of the event. So you can't see the raw original event sent to the solution, and this shouldn't be the case, I think, in the CM solution. So what is missing? Basically, CM no longer needs to be for security only, at least. CM focuses on security analysis, which is important aspect, of course, but CM are able to comprehend also general data analysis and log management aspect, and we will try to talk about them today. So CM relies on the data that you are sending to the system already. So the system is working on the basis of listening for other software on your architecture. And the question from our side is that if the system is already gathering data, why can't it gather the whole data, 100%? Why it's only gathering only the security related data? And the answer is relatively simple, that those softwares are not able, because how they were constructed, they are not able to understand custom data, for example, custom applications or data outside of security, and also the amount of data from every point, from every aspect, can be overwhelming for those systems. So that is basically, in the shortcut, why we are limited in most of CM solutions to that aspect. And also, don't get me wrong, there are CM solutions on the market which can gather almost every data there is. There are a few of them with the CM capabilities, but the issue with them, on the other hand, is that while you are gathering a lot of information and a lot of data to that system, the licensing cost grows really fast. So this is a huge problem, a little bit like an addiction, where if you are limited to that tool and you want to, expand the data you are gathering, then the licensing cost will grow. But leaving this licensing issue aside, the same fact that there are tools that are able to gather any data on architecture, it proves that it was wrong to assume that the CM is only for security, operations and not for IT operations or other departments. Let's look now at the typical sources and overview of them. So what SIEM can index and what can we put into that solution. So the typical sources for most SIEM solutions are like Trend Micro, Cisco ASA, Cisco IDS, IPS, Oracle, Microsoft IIS, FortiGate, and so on and so on. Microsoft Exchange. So those are examples of typical sources that are feeding the SIEM solutions. And now let's look at the use cases for those sources. And here we see the example of Trend Micro use case, where we are gathering the Trend Micro data analysis and present it in form of a table, where we can see the, for example, severity of issues, group of issues, what was the action, and what was the category with the name. On the other side, we have the statistical view for category, action done from the Trend Micro, and what is the count of those events. Here we have the SSH possible brute forces statistics from source IP and destinations IP. What was the action, and on the right side we see that there is also the statistics for SSH, which one were blocked and which one were not blocked, basically. And below we have the same thing for SMTP statistics, whether it was blocked or not blocked, what is the source IP, the destination, user, and so on. And on the on the right side we have the statistical view for the SMTP with the action, name, and count of those use cases. And here we see the example of alerting rule for Trend Micro. And we have a question: what about a disaster recovery planning, how it should be? I will try to answer that on the near the end of the presentation. Then we can talk freely about the disaster recovery and the questions regarding other than the planning of the presentation. Okay, so stick to the end, and I will try to answer every question. Okay, regarding the alerting rule, here we can see as the Trend Micro virus detected. This is the simple rule where we can basically search for a simple string. We have a field of category and the value of virus. We are looking in the time frame of 10 minutes, and the minimum number of events has to be at least 10. So this will, if those conditions are met, this will trigger the alert with the notification that something is wrong, and Trend Micro has discovered it. Here is the use case for Cisco ASA source, where we are looking for a specific Cisco ID. And if that Cisco ID has been discovered, then there is a notification alert is triggered. And this is good for this is good to have those standards and those typical sources, because those companies are really big and serious, and they have their own standards, meaning that we can basically look for a simple like here ID, and then we are knowing that what this ID means, and we can take action. Should be an alert, or should it be just a warning, and so on. This is use case here for Oracle, where is max licenses exceeded. Same thing like the previous one, where we look at the Oracle code in the time frame of 15 minutes. If those conditions are met, then we can trigger the alert and send the notification. Mind here that in those screenshots I've took, there is a alert method of none, and don't worry about it, it's just not selected, but you can change and choose desired alerting method, notification method. This is the FortiGate attack detected, same case. I mean, very similar. We are basically searching for a string of attack and a field of action with the value detected. So we are combining two strings with a logical operator of AND, and this is a simple rule that will trigger the alert. Here is a little more complicated for the exchange. For example, the alert rule of increased amount of incoming emails. And in this rule, we are looking for, basically we are excluding the fields that would make alert trigger false positives. So we are excluding them at first. Then the rest of the data that is gathered by the alerting rule, we are grouping by the sender. And if the sender have sent the large amount of emails, then this alert is triggered, and we are calculating the large amount by comparing the time frames. So we are comparing one time frame to the second time frame, and if the actual time frame right now is, like here, spike height is 3 times bigger than the previous one, then this is the sudden spike that was unexpected. So we are calculating the time frames, and based on that we are deciding whether it's a sudden spike or just a slow growth. Because if it's slow growth, then it's okay, then the alert will not be triggered. But if it's a sudden spike, then there is a trigger. Here is a popular and again simple use case of HTTP 500 errors. Spike, again, same thing. We are looking at the query of response status code of 500. And if it's this time the time frame is 5 times bigger than the previous one, then this is a sudden spike of 500, meaning that probably maybe some service stopped working, or any other issue. We can correlate that later on, but basically this is monitoring for 500 errors. One of the last alerting rules for DNS, a little more complicated here again, where we are excluding, because we are looking for anomaly in geographical region, then we have to exclude all the countries that we know how behave, and we can monitor them individually or by different standards. So for anomaly detection, simple one, we have to exclude all those countries we know how to behave. We have to look at the other parts, and again, using the spike method, we are comparing the time frame, and if a new country, maybe not new, but if a country that we didn't exclude basically have sudden spike of activity 3 times exactly, to be exact, then the alert is triggered, where we are grouping for of course we are creating the groups for those countries, so every country is measured and calculated individually in that alerting rule. And at the end of these use cases, we have a feature of where we can look at triggered alarms and correlate them between each other. So here we are creating a new alert based on the triggered alerts. So here we are looking for multiple VPN authentication failed alert and VPN authentication successful. So this is a simple use case where within the time frame of 15 minutes, the multiple VPN authentication failed has to be triggered 3 times, and the authentication successful must be triggered 1 time. If those conditions are met, meaning if those alerts were, this one was triggered 3 times and this one was triggered 1 time within the time frame of 15 minutes, then we have a notification about the error in this case. Now let's look at the new scope, meaning the custom sources. We have a new question: is event collection agent-based or agentless? Both methods are supported. We can use agent and agentless. Those aspects depends on the basically on the policy of the company, meaning that if for any reason you are avoiding installing the agent and you have some option, like for example Windows WMI, to send the data remotely, then we are supporting it. What about event collection capabilities, bandwidth throttling, caching, failover, health monitoring, and so on? So this I think I will be talking about later on. If not, then we will be back to that question near the end. And can you clarify how CM can improve the accident response managing processing of security incidents? That also be covered in the presentation. So let's move on. The custom sources. So the custom sources are basically everything that is not predicted by the standard CM solutions, meaning that if you have your own application and you want to send them to for calculation and so on, you can do that by using most of the CM solutions on the market right now. You have to have dedicated solution for log management, calculation, and so on. And also that I think we are missing a lot when we are gathering only security data and not the infrastructure and other aspects of our businesses, because the point of CM, in our opinion, is to have the whole picture, the full picture of the company and architecture and how it behaves. So having those custom applications, the point is to also give you the possibility to correlate and to parse and insert the data into the system among other sources. So for example, the NetFlow, custom applications, like I said before, performance measurement, SLI and KPI calculations, and other. So our idea is to have the full picture of architecture in your company, in our company, and that is something we believe that CM should be able to do. So I've grouped those custom sources into 3 general groups, which is the infrastructure, security enhancement, and businesses. So let's first look at the infrastructure, meaning that we are looking at, for example, operating system monitoring, which is the CPU usage or memory usage, or hardware monitoring like disk usages and input and output operations of the disks, and so on. So everything related to infrastructure. And sending the data into the system and having them in any state is one thing, but we have to focus that this data in the system will be in good condition. So we have to take care of parsing, enhancing, and normalizing. So parsing is the section where we receive the data, the system is receiving the data and is making sure that the data is classified correctly. So every field is extracted, and so on and so on. Enhancing is the section where, for example, we have only the identification number in the data, and we know what that identification number is, but it is not pointed in the data. So we can add during basically during the parsing stage, we can enhance the data and add a new field which will describe what that ID means, and whoever will be reading those data will be able to read what this document and what this event is all about. So we are enhancing the data, we are extracting information and enhancing it based on what we already have. And then is the normalizing part. The normalizing is the section where we are bringing everything to a let's say common scheme, where our data is normalized everywhere, and we have common features which will be helping a lot for correlating the data and understanding it without necessarily looking at unique sources. With the proper structure, we can easily create visualizations, alerts, dashboard, and so on. Because the data is normalized, we know what we have, we know what it looks like, and we are able to work on it. And this process basically applies to any data, meaning that this is the infrastructure we are talking about right now. But if we are wanting to send, for example, the NetFlow data or custom application, then this is the same process. We are parsing, enhancing, and normalizing it. So let's look at that. Here we see, for example, a visualization of logical disk, where we can see megabytes per second visualization here totally, average disk QE in total. We can see the disk free spaces over a time frame. So we are able to see if there are sudden spikes or sudden drops, how it behaves over time. Then below we have reading parameters on average for the disks. So again, if the disk is failing, then we could see any anomalies with the naked eye, basically, that disk is not behaving properly as expected. Or we can even check if I don't know, we've bought a new disk and we want to see if the inputs and output or reads and writes operations are as good as the manufacturer stated. So we can connect this disk, set it for monitoring, and we can see how it behaves if the standard of the disk is as manufacturer stated. So we can double check everything. Then we have the visualization of those logical disks in the top 10 view. So what is the which disk has the top reads times, and we can see that it's the M disk in this case. And at the bottom we see that the logical disk current disk QE length. So basically this view of summary current disk QE length is the, like I said, the summary view, and here is the same thing but put against the timeline. So we can see not only the average summarized metric number, but we can see how it behaves over time. Here we have the view of the memory. Starting at the top left, we have the bytes usage. We have then the pages per second usage, and the memory usage overall. At the right, there is a memory usage against the timeline. So this is the summarized, and this is the view over the timeline with the per 5 minutes view. Below we have the memory available in megabytes and memory available in bytes. So those are maybe not so effective dashboards because they are showing something that is working correctly, and this is funny because when you are looking at something that is working correctly, then most of the time this is boring. Only when something is breaking, then something interesting is happening. So this is the case here. Everything is working more or less correctly. Then all the charts are just flat and everything is okay, and this may seem boring, but the key here is to see that we are monitoring precise aspects of those infrastructure. So below we have the memory pages per second over the time. Then we have I can read the small font, the pool count, memory pool count, and the committed bytes, all against the timeline. And the use cases of alerting for infrastructure monitoring are like here. For example, we can monitor high CPU usage, where basically this is rather simple. We are bringing the average value of the CPU usage, and within the time frame of 5 minutes, we are looking if it's exceeded the threshold, and this threshold in this case is 50%. So 5.0 means 50%. So we are looking at the alert of where we don't want on average that our CPU will be higher than 50% per 5 minutes. We can do same for the paging, where we are grouping everything by the host. So we can basically alert the whole group, the whole aspect of infrastructure or parts of host. But in this case, we are grouping per host the paging, the alerting. And again, over the time frame of 5 minutes, average value of paging alerting. The threshold here was 400. So if the paging is above the 400, then alert is triggered. And here we are monitoring the inputs and outputs of the disk over 5 minutes. The average value of CPU I/O weight, and the threshold here is the 20%. Okay, so now let's look at the application performance monitoring. I think I see a lot of questions. I see. That is good. I will try to answer them as quickly as possible. If something is, what is the perfect CM sizing for 100,000 EPSs? I will have to calculate that, and I will answer the question. I can't bring it up from my head. What about threat intelligence integration? Well, integration with threat intelligence is possible in two ways. We have our own machine learning tool, and we are able to do prediction within the CM. And if you have any other tool, then I believe we will be able to integrate with it, as long as it is able to send any data through TCP, syslog, or even write to a file. Then we'll be able to integrate with that, and maybe even synchronize those two tools. Prediction in general is available in the CyberX CM. So I will mark that question as answered. More than helpful, thank you. Okay, thank you too. Okay, so let's look at the application performance monitoring. So the thing is that the custom and not security, like I said before, the custom and not security related application and sources are either impossible to send to the data, to the custom, to the typical CM solution, or the sending those data there will be pointless because the system will not understand it either. So we believe that this should be the possibility to send those data into the system, and the uniqueness of those data is no excuse for the CM solution to basically accept those data. So like I've said before, it's the matter of parsing, enhancing, and normalizing. So applications have the custom, with the custom build applications, you have the unique structure, and often if you have an application that is dedicated for your company or your department only, then you don't have to stick with some kind of procedures or standards and so on, because you are building your applications only for yourself, and then you are stuck with it and you can't send it to the standard CM, and that should not be the case. It's a matter of parsing and enhancing the data. Basically, if you are enhancing and parsing it properly, then you should be able to take it to the to index, and the CM solution should accept it. But having that, if we manage to insert the data into the system, then after the APM is inserted, then we have a really powerful tool for monitoring, and really huge potential for it to evolve in something greater. So let's look at few cases. Here we have first of all, this is a selector for a type of application, but since it's a screenshot, then never mind that. We have the ratio of calls from the applications. So what is the performance of the calls? And we can see that 50% of the calls of applications are slow, so it's bad, and 50% of the calls are green, meaning the normal calls. We can see the average response, and the green background indicates that it's a very good time, 1 millisecond of average response. Then we have, for example, HTTP error codes per minute. So the yellow code here indicates that this is not the best outcome, 100, 150 and 85 per minute. Then we have the total exception per minute, which is the 477, where the orange color indicates that is more to be expected from those results, or not satisfactory. And then we can look at the response time over the timeline, the response time distribution, and response time in milliseconds over the timeline. So we can see here that there is a maximum and minimum. Well, the minimum we can't see because those bars are hiding it, but there is a minimum time and the maximum time, and within those 2 times applications have to comply. So we have monitoring of 2 applications, and then there is the errors per minute visualization over the timeline. But the same thing we have here, and here we have the error codes per minute and exceptions per minute. So basically we can monitor those 2 aspects where, for example, we can treat error as something that application, if the application have an error, then it is writing the error codes, but other than that it's working properly. While the exception might mean that the application is no longer able to continue its working, so it needs I don't know, restarting different instance or something like that. The exception is something more serious. We can monitor the calls per minute divided by application and average response time per application. So we can see that one application is slightly better with the average response time than the other. We can compare the average calls, not even the average calls, we can compare the precise calls per minute with the error codes per minute, so we can see roughly what percentage of calls end up with the error and what percentage of the calls were successful. So here we can see that the error codes, the errors per minute are quite stable. Then we can compare the infrastructure errors against the application errors. So we can see the simple correlation. If infrastructure errors has sudden increase or application error if has experienced sudden increase of errors, if we notice the sudden increase of errors, then we can see if this is correlating. And below we have the URL monitoring, where we can see the application, which URL were visited or which URL were visited by application or user. And then there is a top times taken by URL and by the session. So we can, if we have noticed an increased time of call from application, then we can identify whether it was the URL that is causing the issue or just the session. And here we have the table visualization, where we can see the simple aggregation of data, whether it's the component, the session ID, what is the result, was it the successful error, and then additional info with numerical aggregation like counts and error codes and so on. So we can, with this, we can check whether the application failure results from single component failing or multiple component failing and so on. So this is the statistical data that can be used. And alerting aspect of that would be, for example, high response time, where we are monitoring, for example, here we can monitor 3 applications or more, or we can add 1 application or even all of the application with the response time. And we are taking the response time, bringing it to the average value and comparing it against the threshold over the time frame. And that would mean that we are calculating the response time, the average value. We have the threshold of 300, so we are checking if the average value is more than 300 over the 5 minutes time frame. If it's higher, then this is an alert. If not, then not. High error count is basically the same thing, but only for errors. We are grouping it only for per applications. So the error count will be per applications, and the threshold is 100. And here we have the example of single component failing. So if we have this component might be understand, for example, like library maybe of application or something like that, or even different application where we are counting the errors and grouping it by component. And if there are more than 50 errors, the number of events is greater than 50, then the alert is triggered per component. Of course, we are grouping per component. Now let's look at the SLA management and KPI. So basic question is, we are monitoring the infrastructure, we are monitoring the application, and basically calculating the performance of it. So what is the difference between the application performance monitoring and KPI? Well, not so much. There isn't much of a difference. The difference is that the application is one single thing, and it's a little bit, I would say, easier to monitor it. And KPI sometimes are calculated based on many other things, but we are already doing it anyway. So basically this means that we can also calculate the KPI and SLA. That would require a slight reworking of parsers and enhancing, but other than that, it's basically the same mechanism of calculation. And KPIs have the this one problem, let's say, that their thresholds are very different, and sometimes it's harder to exactly say if the KPI is at the good state or is it below the expectations. And with the to remove that problem, we have the percentage mode, where we can bring all the values to the percentages and in the visualization, and then we basically can, with the naked eye, say that this is below the expectations, this is all right, and this has to be immediately fixed. So bringing values to percentages is really easy, and the visualization then is more readable. So those are use cases for KPI calculations and SLA management. So here we have each 3 rows, and each row is pointing a different KPI. So in the first row we have NYBOASD KPI with 3 aspects of visualization, 3 visualization basically. Visualization of traffic light, visualization of summary, the metric visualization, and the visualization of the chart against the timeline. All of those visualizations are based on one KPI. Same thing is below for the CA VT-CDA KPI, where we can see if the KPI is behaving properly, and at the bottom is exactly the same thing, but here we can see that the general value of the KPI calculation is 96%, but it's okay, as the traffic light is showing it's within the expectations. But we have one interesting thing here, where under the traffic light we can see that the expectation is 80%. So the KPI shouldn't drop below 80%. The general value is 96%, so everything is all right. But on the timeline, we can see that while the time was going and the KPI was running, we can see that there were 4 cases where it drops below the 80%, so below the KPI expectations. And now everything is depending on the, I would say, the SLA. So depending on the agreements and so on. So if we are monitoring per, let's say, month or day those KPIs, then such small downtimes are not important and everything is correct. But if the KPI should be at 80%, 100% of the time, then those those drops should be notified. And what can we do with such use cases? Well, basically we can monitor them by alerting, like everything else, like for example APM examples that would work the same way. We are bringing the value, comparing it. If it's below the expectation, then we can send the alert notification, even run the script which will automate some aspects. Here is the second view where we can calculate. This one is interesting because the OSM KPI has the expectation of 99%. The actual value is 95%, but here we can see that the KPI is built with two components. So within one calculation, one KPI, we have to monitor both components, the OSM 001 and 002. And here we can see that the 001 is expecting a little, is behaving a little worse than 002. So we can monitor and calculate the KPI with no difference if the KPI is built by many components or just a single component. That is no difference for us. Same thing is for the CIK calculation, the general, the traffic light and the timeline, but here is everything is okay. Like we can see, its expectation is 99% and 99% is general calculation. Sorry. Now let's look at the aspect of security enhancement. So IOC and MISP. IOC stands for indicator of compromise, and MISP stands for malware information sharing platform. This is a big deal. This is really important because MISP is a multinational, like the name suggests, platform where various companies can connect to and exchange information about the malware. Those integration with such database is huge advantage for security because we are able to correlate more data. And the other side is that it helps to protect against the unknown threats just emerging. So let's say that, for example, I'm from Poland. So in Poland we discover new emerging threat, and we are connected to the MISP. We take the fingerprint or the footprint, whatever you want to call it, of this malware, and we are sharing it with the within the platform. So it doesn't matter if we manage to beat that malware or not. We are just identifying it and sharing the information. And as the time passes, the malware is progressing, and for example, it emerges in, let's say, Egypt. And if the company connected to the MISP, if the company is connected to the MISP, then it can download the information about those malware, the fingerprint, and be ready and be able to recognize the new threat within the region, because somewhere else on the world this threat was identified and information was shared. So this is a really big advantage. This is how the MISP look like, but in my opinion it's pretty ugly, and it doesn't have to be pretty. it has to work. We are integrating it. We don't have to look at it. And basically we won't be looking at it. And so here we can see the published information about the malwares, who are the creators, the ID numbers, for example, here we have the attack patterns of those malwares, additional information, and so on, the tags of the malware, and so on. So a lot of information. And integrating with that is relatively simple as long as you have the access for the MISP, because we can download those information and integrate them with the within the CM solution. Then when the information is inserted into the CM solution, we can compare the two aspects. So this is maybe hard to see, but what we can see here is the table of events where there was a recognition of a malware attack, the ZIUS to be precise, of a Trojan. What is the exact object and what are the tags? So for example, here we can see the bad URL and the MISP blacklist. MISP blacklist mean MISP blacklist mean that it appears on the blacklist from the MISP, and the bad URL means that it was recognized based on the URL. And the alerting is for that is really simple also, where we have a dedicated let's say method for alerting that. We are monitoring the databases from MISP, and we are comparing values from those databases to the values into the CM. If there is a match, then of course we have the problem. Now let's look at the correlations. The correlations are really important, because if we are gathering a lot of information, then sooner or later we will be asking ourselves what does it gives us, and the correlation is the answer, where I believe that there is no situation where something in IT happens without a reason. If, for example, if you take a simple logging of a user into the interface, user is typing username, password, and hits the login button. But behind that, behind the curtain of those user interface, there is a whole chain of events. So the application for logging is registering the user and launches the mechanism which, for example, connects to the database, check for the username and password, verifies that, and so on and so on. So there is a whole chain of events, and everything within that chain of events was caused by the simple click of a login from a user. And key of understanding the correlation is having the whole wide perspective. So we are not looking at one aspect. We are not looking at, for example, the web server. We are looking about the databases and everything else. And the security aspect is only the part of this whole puzzle of perspective. We have to have whole view of everything within the infrastructure, then we can correlate it. And here is an example of maybe not the prettiest correlation, but really effective. So we have the security perspective, the business perspective, and infrastructure perspective. And security perspective has the visualization of high-risk attacks. And we can see that there was a such case, and it was the denial of service attack. And this denial of service hit some sort of webs within the company, and the web traffic went down. With the web traffic going down, we see the effect of business sales going down. So one situation of one simple attacks had three different aspects. And without the correlation, we see three different perspectives. We can see the security perspective, which, for example, look at the attack and wonders, okay, why this attack wasn't blocked, why, how can we avoid that in the future, and so on. Where the infrastructure perspective looks at their own data, and they see that the part of the whole website is going down, and they start wondering, okay, what is this? Maybe the databases are wrong, maybe the connection, maybe something else, and they are searching the solution. And then there is a business perspective, which they look at the sales going down, and they are, oh my god, what's happening? And they may be thinking, okay, maybe the marketing campaign went wrong, maybe something happened on the market, maybe stock exchange, something happened, something bad happened there. Every department has its own perspective, and what is happening is that every department is basically wasting time finding the solution. With the proper correlation, we can see, okay, there was an attack, we have a attack on the web aspect of our infrastructure. The attack was sadly sadly successful, so the sales go down. Okay, so now we can focus on that. Everyone knows what happened, and we can fix it. So we don't have to look blindly what happened. We can see the whole correlation, and this is the example how everything is connected, and how SIEM solution is not only dedicated for security operations. It can be used by every department. Basically, whoever stores the data will find the usage for this solution. Now let's look at the data warehouse. So we have a lot of data. We have the infrastructure, we have the APM, we have MISP, we are able to correlate all of the data, and what now? Now there is a situation, there is a, how to call it, there is a problem with overwhelming data, data overflow, over information in general. And this is a simple case where you, for example, stand in the middle of circle, and let's say few people will be around you, and everyone start to shout at you something. You won't be able to understand none of them, because everyone's shouting against one another. So you have overflow of information. Same thing can happen in infrastructure and basically in the monitoring tools, where you have too much information and you are unable to pick the incidents and so on. So this is really important to have ability to step one level higher and have the general view over things, and still be able to see the issues and incidents and potential problems. And if those groups will be overwhelming, we will have too many groups, then we go again a level higher when we monitor the groups, which this can go infinite times upper and upper as our infrastructure will grow. So those are the use cases here. For example, there is monitoring of the warehouse where we can see already correlated average response time per application. So we have few applications running, and we have the APM aspect of it. There is a aspect of database response. We can select a specific host if we want to adapt whole dashboard to specific host within the warehouse. We can see the few applications and how many applications are running and how many applications are stopped per application. We can also meaning how many applications are running, I mean how many components of the applications are running and how many components of the application has stopped. So we have one general application, so many components are running, so many components are stopped, are not running. We have the ability to view the partition of the data and correlate. For example, here we have the correlation of active QE, sorry, the QE waiting and active queries over the databases. So in other words, waiting query and active query for the databases. So we can see how efficient is the database in responding. Here we have the CPU per application view, so we can see the in general application with all of the components, how many CPU is using in general or per host if we choose so. Here we can see like for example here we can see how many applications are running per host. So we can see that here is 593, 525 per host. But also applications are categorized by group. So we have applications from audit group, from service, from connectors, and business applications. And we can see also how many applications are running from that selected group. Here we have an interesting view where we are looking at a selected group of applications, like for example here the connectors. The inner circle shows the hosts, and within the border of the host we can see specific applications running regarding to that group. So how many applications, how many specific connectors are running within that one host. Then we have average time response from database based on the application, and we have the heat map of average response time per host and application. So we can see that this application on this host is having a high response time, and this indicates a situation. Here we have a situation where we are monitoring failed important connectors. So every application has its own priority. In this case, for example, there is a priority 1 to 5. So we are monitoring high priority. So let's say we are monitoring 3 and 4, and here they are. So inner circle will be the host's name, the hosts, and within the border of one host we can see the priority of the application and how many of the application from that priority from that host has failed. So this is an example of connector, but we can apply that to everything else. So we gather information from many sources, from databases, from applications, and so on, to build the whole warehouse. And to monitor that, we can use, for example, detecting new application in environment. So when application is launched for the first time, there should be an alert, because maybe the application is malware or something else. When you have a big infrastructure, then you don't always control what is running, and you don't always know exactly what is running where. So alerting that is a good idea. So we can look for applications and the time frame of 30 days, and we are grouping that by host. So we are looking for new application based on host, and if there was this application did not appear within the 30 days, then an alert will be triggered. Now let's look at the asset management. Let's only see if there are questions that I should be answering right now. Okay, I think I will answer all of them till the end, on the end of the presentation, which will not take, I think, much more time. We are mostly we are near the end of the presentation, so let's continue. Let's look at the asset management. So we have a good picture of what we have thanks to monitoring and correlating all of the data. We know what we have in our system, and we know where we want to go with it. If you think about it, that is a really huge amount of information to gather within one system, and that huge information, that huge amount of information must be waiting for a user to use that. So when a user is using the CM solution, he should be able to look on every aspect of those many informations, to visualization of security, of infrastructure, connected, correlated, no matter. There is a huge amount of information, and user should be able to use them freely, of course, within the burden of user permissions. But CM in general, CM tools should be able to comprehend that amount of data, and we know that some of them are not able to comprehend that amount of data, but they should. Now we don't have to basically stop here when we have the warehousing. We can go even further with the CM, and we can look at basically the asset management. This is how it would look like, for example. So here we are grouping all application, all hosts, application server databases and containers within the one statistical view. So this is monitoring on even higher level, on even more dynamic infrastructure and environment, and I will explain that in a second. So we can monitor the, for example, top open tickets from what are the sources of those tickets. We can monitor the operating systems on how many we have them in general. We can see which are the top 10 used CPU of those hosts, and both for memory. Those are regarding the Unix, and below the same thing regarding the Windows. So the CPU usage top 10 and the memory usage top 10. Then we can look at the basically the containers, and the containers are when you are using containers in production, then your environment most likely, not always, but most likely is quite dynamic, and you want to know how many pods are running, what are the statistics of those containers, and so on. So we can see here, for example, that we have the 18 running pods, we have the average CPU of 280 usage over those pods, and same for the memory usage, and so on. So we have a quite high view over the monitoring, and we can present that also on the timeline, where we are looking at the CPU usage in general, the pods memory usage in general, or we can monitor one against the other with the network usage. So here is a simple example of network monitoring. Then we can monitor the nodes, what are the usage of the CPU per nodes, the inputs and outputs of the disk, and the general load. What are even the uptime of the nodes in the seconds. So here we see the over the timeline, the CPU usage and the node disk I/O, so inputs and outputs over the time. And here we can see that also on the same visualization we are able to correlate the data from different sources, where we are monitoring the load of different aspects of the load of the one host. So different aspect of the asset management is application management. And here, before I said that the we can monitor the dynamic infrastructures, and this is the case. It's not the prettiest of the visualization, but basically it works. It shows what it should. So we are looking here at application performance and application management, maybe more management than performance, because we are looking how many applications are running. And the dynamic part here is that we don't know what exact hosts will be running, which exact host will be running applications. So we are not monitoring the per se application on specific hosts. We don't know which host will run which application. We have to be also dynamic to monitor the running application, to monitor the running host, and so on. So here we can see that what is the application name, on which host they are running, and in which number those applications are running. So one application have many instances, and those instances has to be counted down, and here we have the presentation of it. So for example, here we can see the missing application. Maybe it's all right, maybe it's something that we should take a look at, and we are missing the blue bar, missing the applications. So we are able to do dynamic monitoring, but also we are able to do monitoring. Here is the example of Apache. So we are monitoring open slots of specific ports. Here is the port of 80, of I believe it's 443, 8008, and so on. So we are monitoring how many slots are open on specific ports, and this is important for example, few of denial of service attacks, where you can see that the slots or the sessions have run out, and then yeah, basically the denial of service has ended successfully. Here is the same case where everything is stable, so nothing interesting here, but we are monitoring the access counts per port, the busy ports. Here is the readings and sendings per port, and so on. So Apache statistics. And now basically having all that, the natural things to evolve into is the configuration management databases. So CM, like I've shown you, the CM can monitor many aspects of infrastructure, of applications, of security, business, and so on. So the configuration management shouldn't be difficult. It's just a matter of monitoring another files and looking for changes, or monitoring if it's if has been moved, or and so on. So CMDB is natural extension of everything CM should have, and once it reaches the stage, then it would be the true heart from the top to the bottom, where we will be able to always check for everything that we need. We can check for errors, we can check for configuration, we can check for monitoring containers or network, and so on. So the whole story of this presentation is that we have basically 2 points. The CM should be able to accept all necessary data. All necessary data, not only those related to security, every data there is. And I believe that I've showed you that this is possible. I didn't show you every aspect and every source there is, but there is a lot of those sources, so that would take a lot of time. but nevertheless, a CM solution should be able to integrate those data and gather every text data there is together. And the second point is that the CM as the true central point of architecture should join the teams, not to divide them. So we should stop with the situation when one department has one monitoring tool and other tool for other stuff, where the other department have other tool, and so on. Let's join those teams, because we have the tool that can satisfy those needs from both, where analytics from business department can analyze the sales or the predict clients' preferences and so on. And also the infrastructure team can monitor the performance of the hardware and software, and the security team can look for issues and analyze them. We have one tool and we can join those teams together, and there are many reasons for that. Whether it's time saving, so also the money saving, fixing things faster. There is another aspect of money saving, because you don't have to maintain many tools for many departments. You can buy one tool where all departments will take part of, so we will have the higher budget, for example, if we have to have, and so on. So there are many cases, and possible integrations. Basically, there are a lot of them, but I thought about what integrations I should point out to, and I figured that the most important integrations are with the other similar tools, other CM solutions, because CM, if we want to build the CM, which is the true heart and leader of the company, we need to have respect, and we have to be able to connect with other very similar tools. Only because if we are not doing that, then the transfer from one tool to another is really risky and time consuming, and means only trouble. So we have to think about it, and to have a possibility, and basically we do have the possibility to integrate with other CMs. And then there is a choice of a customer, that whether he wants to with time migrate everything to one tool, or maybe he wants to stay with many tools. It doesn't matter. We have to have the options. Basically, every CM solution should have the option to integrate with other solutions, because this is the only way to basically work out. So that is all from me for today. Now, like I've said before, I will look at the questions, and I will answer them as best as I can with the application. Okay, so from the top, what about disaster recovery planning, how it should be? And we have one answer. Okay, so the disaster recovery, it depends what you mean, because whether a CM solution have disaster recovery, yes, it has the scenario of high availability. So the data is replicated, and whether, for example, few elements of the let's say, databases of those CM solution will go out, then the whole CM will work properly, because well, there is a safety, there is a high availability aspect of the CM solution. And if you mean the disaster recovery of the other, for example, databases or applications or softwares, then I think there is a possibility to basically monitor every aspect of the like I've basically showed, even the configurations. And if there is some kind of disaster in something that is outside of a scope of a CM, then you are able to recover that to the original state thanks to monitoring of the CM. So you know what configuration you have, what databases had, and so on, so on. So you are able to replicate the most important aspects of the data. And if you are talking about also the prediction of the disaster happening, then there is a possibility of monitoring infrastructure within those borders. So we can see how much CPU is used, and thanks to machine learning and simple predictions, we can more or less predict when will be the time for disk to run out and so on. So I think that is the answer. If you have any other, then please send them. Is event collection agent or agentless? So agentless, I already told you that this is the matter of your preferences. It can be agent and agentless. It's also the matter of what is the possibility of the system that we want to integrate. If the system is physically not able to send any data or to even write to a file any information, then it's impossible to be monitored anyhow by any tool on earth. If it doesn't have the API, if the software doesn't send any data outside, and if it's not writing any logs or nothing, then it's really hard to be monitored, but we'll try. What about event collection capabilities, bandwidth throttling, caching, failover, health monitoring? So the CM solution should have, all of them should have, for sure CyberX have the health monitoring, the auditing, internal auditing, and that internal auditing is monitored from the start. So we are able to see if something is wrong with the CM solution, with the CyberX. We are also able to monitor the same way other tools by performance monitoring, basically. So we have this health monitoring of the CM, but also the health monitoring of other aspects like databases and so on, by monitoring the disk usage and CPU and so on, and the capabilities depends basically on how much data do you have, and if you have a lot of data, then you maybe need to have a little more parsers. So the parser part is something that maybe you need to evolve. If so, then we can do that with no problem. So I wouldn't be worried about failovers. And also, if the parser will go out for any reason, then we can during the deployment we can also take care of the caching or the buffering of the messages. So if the parsing and even the whole CM will go down, so then with the proper architecture we can save the messages from going to nowhere to be stored and waiting until the CM will be available again. So I hope this answers your questions. Can you clarify how CM can improve the incident response management process of security incidents? So CM solution, the CyberX have the inbuilt the incident management, and that will be I think we can show you this on the POC, or if you are on the spot on the security conference, then you can, I think, look for someone from CyberX and we will be able to show you the incident management from within the CyberX. And basically the improvement of incident management is improvement of incident creation, I believe. So you don't really improve the incident management and the incident system. You improve the mechanism that creates those incidents, because if you have the list of incidents and some of those incidents are, for example, false positives or not important, then this is not a problem of the mechanism of incident itself is the problem of mechanism that creates those incidents, and that should be improved, meaning the incidents are created by alerting. So if you are not satisfied with some incidents or believe that those incidents should be fixed, then we are looking at the alerts that created those incidents and think about how we can improve them. And CyberX alerting tool is quite efficient and flexible regarding the conditions that you throw at them. So I think this is the way. Short answer is that how to improve the incident response and management. Basically, improve the system that creates those incidents. Okay. What is the perfect SIEM sizing for 100,000 EPSs? Those are pretty large number, and same here. I'm unable right now, sadly, to look at my calculations. But this is something like Mr. Kevin Cardwell replied that there is a sizing chart where you can calculate what kinds of architecture you are needing. 100,000 EPSs are a pretty big number, but this is nothing that we are scared of, like I've showed you before. For example, here we are gathering information from 1,719 applications, along with 373 hosts and so on. So those are big amounts, those are big numbers to gather information from, and we are able to do that. To plan the architecture for that, we need to calculate it. With no problem we can, but right now I'm unable to pull up the calculator. So you can either send me a message and I will reply as fast as I can. You can send the message to Noor from CyberX. I've sent in the QA somewhere, I've sent the email to Noor, and also you can contact the CyberX officially, or you can basically look for, if you are on the Arab Security Conference, you can look for CyberX, and they should be able to calculate that. What will be the level 1 and level 2, layer 1 and layer 2? Well, for sure you need to at least, I would say, 3 first layers, if not more, but 3 should be enough, giving you the high availability aspect of layer 1. And the layer 2 would be hard to say, really. Depends on what kind of data. So this is a tough question regarding the layer 2. Okay, so thank you for the question. If there are, I don't see any new, I think, right now. Let me check again. No, I think that is all the questions. Okay, if there are no other questions, then I appreciate your company during this presentation. It was my honor to be able to present that to you, the CM solutions, and thank you for listening. If you have any questions later on, if you will have any questions later on, then please just feel free to contact me through the Huva app or through CyberX, and any question you will have, I will try to answer as best as I can and as fast as I can, okay? So I think that will be end for today. So thank you again, stay safe, and bye-bye.